I'm working today on this 2002 Dodge Grand Caravan with 3.8. A customer concern is lack of power. He said he's been working with not too much power, low power on the vehicle, and he's been having the check engine light for a while. So in this case, how he told me the fuel gauge is being all over the place. So we don't know if that one is related to a fuel pump, a low pressure, or something like that. However, he told me also like the vehicle didn't want to run more than 2000 RPMs and second gear, something like that, and no more than 30 miles per hour. So that to me sounds like the vehicle went into a safe mode, like a limp mode, which is a limp mode is a limited mode reduction of the engine. They reduce the engine power. Like for example, the electronic throttle body does that, like a strategy. Also the accelerator position sensor. Some of transmission problems too, and there are other stuff. So behind it is a strategy for the engineer, from the engineer to disable those components to avoid damage to something else or accidents, because if the throttle body fails and it does its own thing, like it could just have an accident, and they are trying to avoid that on one side. On the other side, they're trying to avoid the customer keep driving the vehicle like that, because a lot of customers, they keep driving the vehicle for very long time. If the vehicle has a checking light on and they don't feel any performance issue, they keep driving like that. Here in California, there is every 2 years, the smog inspection. They wanted to reduce that one to 1 year because of that reason. But the first step I do with this is scan for codes, and then the second step is drive the vehicle. And then at that time, while I'm driving, I wanted to duplicate customer concern one, and the other one I just wanted to be looking at some data and see, for example, this one has a lack of power, so I will be looking at front O2 sensor, upstream, downstream, the two O2 sensor before the catalytic converter and after the catalytic converter. And because when I press hard on the wide open throttle, I wanted to see those two O2 sensors go about 850 millivolts and stay there. So that means to me it has a good fuel. But if I still have a lack of power, I'm thinking about plug cut. But we'll see how this goes. So first is gonna be now a check for codes, see what data we're gonna be picking up related to whatever codes we have. And then also the other step is going to be drive it and feel the lack of power and see if we can catch something on the scan tool, and go from there. And then after testing the components. Okay, now we're gonna scan for codes. Have a little glare here. Wow. I'll be scanning for codes and get information about each code, setting criteria, and possible causes. Dodge Grand Caravan. Yeah, it is our vehicle. Okay, it's okay. I'm gonna go to engine and automatic transmission with AC. Continue. I'm gonna read for codes only. So p0700, transmission fault present. So basically this code is a generic code. The 700 means that the transmission control module told to the PCM to set this code. So we're gonna go to the transmission control module to find for codes there, because this is just generic code, p0700. Okay. p0171 fuel system lean. Well, this one could be a fuel pump. This one has a map sensor, could be the maps too. When they have a map sensor, could be the map. Fuel pressure, air intake leaks on the intake, and we have a p0645 AC clutch relay circuit. Okay, so that one is probably gonna be an issue with the relay, or it's gonna be an issue with a tipo module or something related there, AC compressor. So for transmission fault, gonna go to the transmission module right now and try to find out what is that code, what code is has set inside the transmission control module. p0171, I'll test drive the vehicle, and we gotta graph the upstream O2 sensor and downstream O2 sensor. I mean the sensor, the O2 sensor before the catalytic converter and the one after the catalytic converter. Punch the gas pedal all the way in, wide open throttle, and see how those sensors react. You know, like action for me, press all the way the gas pedal. Reaction, I wanted to see that both O2 sensors go reach complete about 800 millivolts and stay there. AC clutch relay circuit, we may attack that one, I don't know, it's not related to our issue, but we'll go to the control module for, I'm gonna check for one trip, transmission fault present, secondary, no code present. Let's go to the transmission control module. Transmission, it's just send a message, the transmission control module, to the PCM to tell the PCM there is an issue on it. So codes only. Okay, we have two codes on it. Internal TCM p0505 and p0953. I'm gonna see the setting criteria for those and get some information about those. Okay, so I'm gonna go here. The glare is really, I'll get information first about the p0605. Okay, p0605 troubleshooter, transmission. So I needed to go to a different place, I think. What is it? Yeah, troubleshooter, transmission. Code tips p06505 505. Okay. Fine, now here I'm going to move this computer to a different spot and see if I can get less glare, because the glare is really bad right now. It's hard to see here, or maybe here. Okay, it is telling me p0605 internal TCM. Code will set if transmission control fails. Brum read-only memory, self-test. So it basically is an internal issue in the computer. Self-test is done after key on or after cranking engine. This code will put transmission into limp mode. We can see that one. He's saying it's being in limp mode and illuminate the check engine light on. Okay. Clear code, start engine. If code return suspect faulty transmission controller. Code is internal controller failures. No controller repair is possible. TCM must be replaced. Okay. So straightforward. We need a computer. Only thing we need to check is powers and grounds. Okay. What was the other code? Let's go back. Let me see the other code. What's the other code for? Don't remember right now. I should written down those. p0953, 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 code tips, p0953, p0953. It's not here. p0953 is not here. 52 I found. 93. Didn't find that code. Oh, is this one? Auto stick input circuit low. Was that one 92? Let me go back. I think I messed up here and I didn't get the right code. No, yeah, it's not circuit high, but it's about the same system. The 52 and 53. You know, 52 is circuit low and 53 is circuit high. So basically we can get the same, pretty much the same direction there. Almost same troubleshooting system. Oops. 095352. Let me see what it say about this one. Gonna read a little bit on this one. Down chip switch open. What's that one? Get information about this. p0952 auto stick input circuit low. Code said when the transmission is not in auto stick position and up shift or down shift are reporting close below 0.3 volt, or if both switches are reported close at the same time. Monitor whenever engine is running. Possible causes: faulty auto stick switch. Auto stick switch downshift sense. Circuit short to ground. This one is not short to ground, it's open. Auto stick switch upshift sense circuit short to ground, faulty PCM or intermediate wire connector problem. Use the following numbers to locate appropriate wiring diagram. What is the auto downshift switch? I see something here, but I don't know if this is what we have. Auto stick. You can see that one here. Let me see if I will move this switch and see if we get any changes there. Downshift switch. Downshift switch. Auto stick. Okay, I'll move this one like this and check out the data here. But faulty auto stick switch. Yeah, okay, maybe this switch. Okay. Yeah, it is, because downshift switch. Okay, nothing appear here. Okay, so gonna move forward to different. Okay, so the next step is gonna be test drive this vehicle. Test drive and find out about the p0171 and the TCM module. Pretty much we're gonna replace it. I think we're gonna check powers and ground to that one, but test drive is coming up. Okay, we're gonna be picking up some data related to the issue we have. Automatic transmission with AC. So anything like fuel trims, closed loop monitor, TPS sensor, map sensor, and so let's create a custom data list here. Select all, RPM, TPS, closed loop monitor, barrel, map sensor, manifold vacuum, throttle position, downstream O2 sensor, upstream O2 sensor. These pretty much are the two main data I wanted to see, but it's still short term, long term. If we are in closed loop, we can count on it. I can smell this vehicle is running like rich right now. I smell the fuel. Shift lever, what's that means? Shift lever, oh, part neutral safety, okay. You can see the long-term adaptation is the fuel, the computer is adding 24% of fuel on it, and short-term is 0. So we're expecting between these two, short-term and long-term, we're expecting no more than 10% in total. So that is why it's showing the code. Okay, we're gonna monitor the downstream O2 sensor and upstream O2 sensor. You can see the downstream O2 sensor is 920 millivolts, while this one is a 0. Snap throttle, barely we see a 15 millivolts, and this one reacted. See, downstream is reacting. So we have an issue here on the upstream O2 sensor. Let me see the barrel, the manifold vacuum, how that changed. It's on top here. Yeah, we see that one. If I accelerate, I should increase my vacuum. See, if the engine is breathing okay, see, we can see like 20. It should go above 20. Yeah, 22. I release the gas pedal. It should go up. Boom, it should go up. Yeah, see it there, 24. Nice. So that means the system is breathing okay, no plug cut. In this case, I will add propane to the intake and see the reaction of the O2 sensor. At this point, I think the upstream O2 sensor is dead. But we just we need to check for signals on that one too, you know, that way we know there is not an open wire or anything like that on the sensor itself. You know, if it is the sensor, is the wire coming from the computer. Okay, so map sensor. Yeah, we see good response of the map sensor. Okay. Do a wide open throttle. I'll drive it on the road with wide open throttle right now. I'll throw here down to RPMs, TPS. See TPS on top. See the TPS. I'm going about 3 point something RPMs. Downstream 900 and something. And this one barely nothing, so I'll drive it at wide open throttle, first gear here. On first. Got the upstream and downstream here. Wide open throttle now. Nothing happened. You can see there the sensor, the upstream. See, and that fuel cut off there. Gotta test the O2 sensor now and the computer. Okay, so my next step is gonna be testing the O2 sensors, upstream, downstream. I know that the downstream is responding correctly, but in this case, we can see here, I got connected here the O2 sensor wire here. I'm connected to the O2 sensor on the sensor side right here. Very hard to see those. It's very, they are hitting here, but we have 4 wires here at the sensor side, 2 blacks. Normally those are the heater, the 2 blacks, and then I have a white and blue. So the white is ground and the blue is a signal. So I will be checking with the scope this directly here, and we're gonna be checking for the response. And I will propane now, and at the same time we're gonna force this sensor to go lean or rich. But mainly my concern is here, do we have a dead sensor, or do we have a broken wire from here to the computer? So we're gonna do a bypass test with a test light and force full reach the signal of the sensor. If that responds on the scan tool, so that means the wire is good through the sensor all the way to the computer. So my next step is to run the engine, start the vehicle. Okay, and now check on scan data. I already have the setup here, the scan data. So this is my, I'll go to the scan tool. There's a lot of glare here. Ouch, data display. So I got downstream and upstream sensor. So we can see here the downstream is reading 950 millivolt full reach. Downstream is reading about 0. Let me go key on engine off, because they are sending some bias voltage for testing for open and chores. Key on only right now. So we should see some type of voltage here. Okay. Still, this one is reading something, the downstream still reading, 980, but we can see downstream is reading, the upstream is reading 0. They should get to the voltage, the bias voltage they have. It's weird, still reading that one. However, I will, it's getting there something. It's just regulating right now. It was still reading whatever was left over on the exhaust there. You see the upstream is reading about 200 millivolts right now. $250 millivolts. Okay, I'll start the vehicle and add propane to the intake. Well, what I have here is a propane bottle, so I'll open here and I'll press the button here, so that way I have it here to the intake. I disconnect the something here. We're gonna create a vacuum leak first, some type of vacuum leak here. Still my sensor is reading rich, the downstream. We force it to go down, go lean. Currently goes lean. Okay, the downstream, the upstream barely responded. So I'll add some propane right now. Anyway, this one doesn't make any difference with what I'm doing, but for the upstream, I'm gonna press right now. Probably the engine is gonna shut off. I'm gonna add propane, press the button right now. Okay, see the engine just died. And well, so now I'm gonna test the wire from the sensor to the computer. Basically what I'm gonna do is I have my test light connected to ground right here, and I'm gonna force that one too. It's not that working, my test light. What's going on with my test light? So let's check my test light first. It works. It's capable of. It's not working. My test light. Let me see this one first. Okay, so now I'm connected to the positive side of the battery, and I will touch here on my signal wire, and we wanted to see the reaction of the computer detecting the high voltage. You see? Remove it. Touch, remove, touch, remove, remove, touch it. So the wire is good. Unplugged, we can see there is a 310 millivolts bias voltage, so that means it's good. The computer uses that for monitoring for short to ground or opens. And this one has a 610 millivolts, the downstream. So now I'm gonna hook up this one to ground. That way I force it to go to zero. This dropping this bias voltage to zero. See, went to zero. It's connected. Yeah. So then, now with confidence we can put in O2 sensor. Wire is good. So I didn't check the ground, but when the ground is open, usually the voltage goes high on the signal. So in this case it's low, so we got no issues. We check with the scope too. Have it, because I'm gonna be putting I'm dropping this to ground right now. See, zero. Remove it, touch it. Okay, so I will connect this one to power side, okay, of the battery, and now I'm gonna force it like battery voltage. See, remove it, plug it back. So we have a good wire all the way to the computer. O2 sensor is coming up. Now we're going to test for the transmission control module. Well, at this point we're gonna be looking for the wiring diagram for the 3.8 automatic transmission, powers and grounds. The glare is terrible here. Okay, let me first try to identify powers. It's hard to see it like the way how this one is, but one power, another power. See the grounds. This is one ground. Let me zoom a little bit on this one, and this is another ground here and ground here. Come on, this is not. It's not that one. Oops. That one. Oops. It's another ground, two grounds. So we can see ground here on pin 57. I think it's 57, and ground on pin 53. And power. This is another option. Not that one. That one is the one I wanted. Not this one. We can see one ground power here all the time. It should be a constant power on these two grounds, and we need another power right here. Key on, engine off. I think it's that one right here. We'll follow these. Yeah. See, we're using the run position something, get power here, and this one is hot all the time. So we're gonna check those two powers and two grounds and call a computer if those are present. Oh, as we can see here, we're gonna look for ground on pin 57, black and red, and another ground on black yellow on 53, and power on fuse battery 55, yellow red, and then power on yellow on pin 8. Okay, that's my next step, is checking those powers and grounds. Basically what we're gonna do is we're gonna start checking for the pin 8 first, which is yellow, and to identify them, the 7, we need to look for a white, brown, and a dark green tank, the one after that one. And that one is gonna be with the ignition switch, which will have power. With the ignition switch off, we should not have anything. And then we're gonna have on 53, black and yellow, we got ground, and 56 is the other one. We're gonna have a constant battery power all times, and we have a ground here on the pin 57. And to identify them, we wanted to check to make sure we're on the right wire, the 57, and the 58. So we'll see if we are checking 57 is black and red, so the one after that one has to be a dark blue, orange, and the one previous that one has to be yellow and red. Okay, we're gonna go through that one. Okay, we're gonna start checking for pin 8 first. I mean, like on the computer, on the ignition, on the TCM, is pin 8, ignition switch out, yellow, and that one is coming from the integrator power module, and it goes through that one, and it's coming from yellow, pin 4, from the ignition switch, and it only should illuminate on the start position, pretty much on the crank position. Okay, so I will be connected here, test light on pin 8, one, and the other one will be on 53, which is the ground. So the test light should illuminate at this point over here. So I'll go and crank the engine. As we can see, we have that power present. One power, 8 is good. So we're gonna move forward with the next one. So now I'm checking here the powers on the pin 50, the ground 57 I'm connected, and all the time on the should be power on the yellow red 56. So I'm 56 and 57 right now, right here on the DCM. And we can see we got, so I'm gonna check now, switch to the 53 ground to check both ground and leave it on the 56, which is constant power, to make sure, you know, the two grounds are okay. I'm moving it so it's hard to reach it here. Okay, podemos ver la luz. Well, we can see here right now light. So I'm connected here on the 2, 53 and 56. So both ground are okay. We check two powers now. The two grounds, one power. We're gonna check on the pin 8 on crank. We already checked it. So gonna check the relay output control now. That one is checks give it power to a relay for the transmission, and that relay send back two powers to the computer. So we're gonna check that the computer is capable of sending that control to the relay, and then see if those two powers are coming in to here, and those all will power up the solenoids. Okay, how this system works. Okay, we check all of those. So there's only one more check we have gotta do, is this transmission relay control. So on pin 15, yellow brown, this signal goes to yellow brown. This one it controls this relay, transmission control relay. So as we can see here, this one should be sending power out here, because this one is constant ground. Okay, so when the computer sends out the control, which is gonna be high side battery voltage, system voltage to here, this relay should close. When this relay close, is coming the power out to this yellow orange here, to yellow orange. We can see that yellow orange. Oops. Is giving power to all the solenoids. Yellow and orange giving power to the solenoids, and also is giving two powers to the computer. Transmission relay out and transmission relay out, 16 and 17, and 15 is the control. So right now what we need to check is, I got the engine running, what we're gonna check is on the pin 15, which you see on pin 15, power coming out. Okay, but I will use my test light, because this is like a very low current, so I don't want to use my we don't want to draw too much current on it. Okay, so I will have connected my test light. I need to have my test light connected to ground right now. It's gonna be here, ground. And then I will have to touch one positive to find out if my test light is okay first. So, okay, my test light illuminates, so I got ground connection. And then at this point, I'm connected to ground. So we should see here on the pins 15 power. Now it should illuminate. So I don't see anything. I don't see anything. So now what I will do is give it power, because apparently if I'm doing a good contact here, what happens is the computer is not sending this voltage out. So I will do a bypass. If I have a good connection right now, I will connect to power side right now on pin 56, which is power, and I will give it power to the solenoid, to the relay. See, illuminates. At this time I'm doing the work at the computer with the test light. I'm sending voltage to the relay, and this means the relays is everything working okay, the relay wires and all the system. So now I get voltage on those two coming into the computer on pin 16, on pin 16 and 17, and the relay and everything is okay. So at this point we need a TCM. Well, we got the approval now. The new computer is seeing. We can see here I'm connected on pin 17 and pin 53. Let me see, 51, 53, yeah, 53, which is ground, and I'm connected on pin 17. You can see that one. And now I just connected my test light, very low amps, like 300 milliamps, and I have it here. So I'm not gonna touch the transmission control on pin 15, and we're gonna see it will illuminate. See it illuminates. So now everything should be fine. We're gonna go through adaptation from this transmission control module, and everything should be fine. Okay, now we're gonna do a hard reset to these computers. I'm gonna disconnect the two terminals of the battery, positive and negative, and get the attached both together for 30 seconds, and that will discharge all the capacitor on every computer and restart, you know, from zero, like all the relearn and everything. So that's next, coming next. Okay, we have it here after replacing the O2 sensor, the upstream, key on, engine off, 416 on the upstream, and downstream 490. Bias voltage on both are even, so we're gonna create a vacuum leak in a rich condition. Well, got my scan. I have my scan tool connected here now, and we're gonna go through now to the pre-learn, or they call adaptation to the transmission control module. We're gonna go through those steps now.